All right, let's jump right in. We're about to go on this incredible journey, looking back billions of years into Earth's history. And we're going to see how a bunch of ancient clues can not only help us understand our planet's past, but also, surprisingly, help us figure out some solutions for our future.
So I want you to imagine something. Picture yourself as a detective handed the coldest case file in the universe, the story of our own planet. It's a story that's billions of years long. And here's the catch. There were no witnesses. So where would you even start? How in the world do you read a story that has no words?
Well, you start by looking for traces, little clues left behind. And sometimes those clues tell a story that'll just blow your mind. Like in Tanzania, where Dr. Mary Leakey found these footprints, 3.6 million years old, perfectly preserved in volcanic ash. This wasn't just a bone, it was a moment, literally frozen in time. It was the first direct proof that our ancient ancestors walked on 2 feet. A single clue that completely rewrote a huge chapter of the human story.
And you know what? These kinds of clues, they're everywhere. You just have to know how to look for them. They make up a story that is literally written in stone.
Now, the main clues in this planet-size investigation are, of course, fossils. But when we say fossil, we're talking about more than just dinosaur bones. It's any preserved trace of ancient life. It could be a footprint, an imprint of a leaf, even a bug trapped in amber. Every single one is like a snapshot, right? A single frame from this epic movie of life on Earth.
But here's the thing. Becoming a fossil is unbelievably rare. I mean, the conditions have to be perfect. An animal or plant has to die and then get buried by mud or sand almost immediately, so it doesn't decay or get eaten. Then, over millions of years, more and more layers pile on top, and minerals slowly replace all the original bits, turning it to stone. So every fossil we find, it's like it won a cosmic lottery ticket against being completely erased. It's an exceptionally lucky survivor. Okay, so we have the clues, the fossils, but they're just scattered pieces of a puzzle. How do we put them in order? How do you build a coherent timeline from this jumble of stone snapshots? Well, it's all about decoding Earth's ancient timeline. Scientists have 2 main tools in their forensic toolkit for this. The first one is called relative dating. The easiest way to think about it is like a layered cake. You just know the bottom layer was put down before the top layer. It tells you the sequence of events, what's older and what's younger. But if you want to know the exact date something happened, you need absolute dating. This method is more like a clock. It uses the super predictable decay of radioactive elements, like carbon-14, to pinpoint an actual numerical age. We're talking thousands, millions, or even billions of years. And when you take all that data and put it all together, you get this, the geologic timescale. This is basically our planet's calendar, stretching back 4.6 billion years. It's organized into these huge chunks of time called eras, like the Paleozoic, which means ancient life, then the famous Mesozoic, the age of dinosaurs, and right up to our own era, the Cenozoic, the age of mammals. Each division marks a huge, dramatic shift in life on Earth, all told by the fossils.
So, okay, we've gathered the clues, we've built the timeline. But, so what? What have we actually learned from all this? What are the big lessons from our dynamic, changing planet? Well, the story the fossil record tells us is just staggering. It's the bedrock proof for evolution. You can literally see the sequence of life changing, with fish showing up in the record way before amphibians, and amphibians appearing before reptiles. But it also reveals a planet that is constantly and sometimes violently changing. I mean, get this. We've found fossils of tropical plants in Antarctica. That's not a mistake. That's hard proof that our planet's climate can shift in ways that are just almost impossible for us to imagine today. And that really brings us to the most important lesson of all. The fossil record, it's not just a cool story about dinosaurs. It's a warning. It shows us in no uncertain terms that massive, planet-altering climate change is a normal part of Earth's history. And it shows us that life has a simple choice: adapt or disappear. Which, of course, leads to the big question. If Earth's climate has always been changing, if it's a natural thing, then what makes today's climate challenge any different? What's the big deal? The difference, it turns out, is all about the cause and the speed. We are now facing our unique climate challenge, and those lessons from deep time have never been more relevant. See, unlike the natural cycles of the past that unfolded over millions of years, today's climate change is happening at lightning speed, and it's driven by human activity. We're seeing major consequences, like ocean acidification, happening over the course of decades, not eons. And that means we don't have the luxury of time. We need brand new strategies to both mitigate the causes and adapt to the changes. So, if the story written in stone is our warning,
what's our response? This is where we pivot from discovery to invention. We have to start engineering a sustainable future.
And humanity has an incredibly powerful tool for this kind of problem solving. It's called the engineering design process. It's basically a systematic, step-by-step method that engineers use to tackle all kinds of real-world challenges, whether it's building a better smartphone or, you guessed it, tackling global climate change. It's really this elegant loop that takes you from an idea to a real-world solution. You start by figuring out what you need to achieve, your criteria, and what your limits are, your constraints. For climate change, that could be reduce carbon emissions by X% with Y budget. Then you brainstorm ideas, you build models, you test them like crazy, and you analyze what works and what doesn't. Then you take what you learned and you optimize the design. It's this constant cycle of create, test, and improve.
And let's be clear, this isn't just some abstract concept. This is the exact process that's being used right now to develop the solar, wind, and other sustainable energy systems that are going to power our world. It's how we design buildings that can stand up to earthquakes. It is the blueprint for building a safer, more resilient world.
So here's where we land. The story of Earth's past, it was written in stone, and it was pieced together by these amazing detectives of deep time. But the next chapter? Well, that's not written yet. That page is blank. It's waiting for us. The history is our data. The engineering process is our tool. The only real question left is, how are we going to engineer the future?